everyone, welcome back for video lesson day 2. It's Wednesday, January 19th, and hopefully the lessons yesterday were not too bad. I know we'd rather be in each other's company instead, but send me some feedback, okay? If there's anything that you think I can be doing better or anything you liked or disliked, please let me know. Send me a message on Remind or email me at the school email. All right. So today, what we're gonna do, it's not gonna be too crazy of a crazy long video lesson. I'm going to do question number 2, which should be, if you count front and back pages in your packet from yesterday, it should be the third, page or side, right? So yesterday we did the front and the back, the first 2 pages, and today we're going to do page number 3, which starts with question number 2. So today what we're going to focus on is graphing triangles and then proving what kind of triangles they are, not just by the looks of them, but by proving the lengths of the sides or their slopes of the sides, depending on what information we get from calculating all of that. Okay, so let's get right to it. All right, I'm going to do question number 2, and then I implore you, I motivate you to do question number 3 on your own. Okay, so that'll be your test to yourself, whether or not you fully understand what you've learned from this video today is by doing question number 3. Okay, proving to yourself that that you have comprehended the concepts that we're going to talk about today. Okay, and then that'll help you ultimately, in the future when we start building even more on this. Okay, all right, so without further ado, question number 2. It says graph triangle ABC using points A, 0, -4. So I'm going to start by graphing that right away. 0, -4. I'm going to label that point A. And then the next one is 0, -9. All right, so that's point B. That's down here. Point B. And then the next point is -2, -5. -2, -5. Oh boy, that's quite a small triangle, but that's okay. We can deal with it. We can handle it. So I'm going to connect all 3 sides. There's C, 1, 2, and 3. Okay, so there's my triangle, and we have to determine if triangle ABC is either scalene, and remember scalene means no congruent sides, so that means nothing is the same. And then isosceles, right? Isosceles means that we have how many equal sides? You know it. 2 congruent sides. Hopefully you were thinking that. And then equilateral. That one, I've got an arrow for that. It has 3 congruent sides. Okay. So that's what we're trying to prove here. It doesn't look like we've got equilateral, but again, we can't go by looks. We got to do the math. So it says explain your reasoning. Okay, so to determine if the triangle is any of these 3, we have to calculate the lengths of each of the 3 sides. So let me erase this A here. Just move it out of the way for a second. Move it up there. Perfect. All right, so what are the 3 sides? We're going to find the distance of each side. Okay, so distance of, and I'll put a dot, dot, dot. Let's find the distance of, let's do AB. That one's kind of speaking to me first. Now, how can I find the distance? I can find the distance by either counting the boxes myself, okay? Or I can use Pythagorean theorem if I want to make a right triangle, or I can use the distance formula. Okay, so those are the 3 methods that we could use to find. Now, since A to B is on that black line, it's actually right on the y-axis, we can count those boxes from A to B. So we could count 1, 2, 3, 4, 5. So AB is actually 5. I'm going to write that. So AB is equal to 5 units, or whatever it may be. Okay, now let's take a look at AC. Let's try AC. AC. Now AC is not on a nice straight line. It's almost like a diagonal. So we can do this a couple of ways. We could do a little Pythagorean theorem. We could do a little distance formula. It's really up to you. So I'm going to do a little Pythagorean theorem. I'm going to go from C to A, or A to C, doesn't matter. If I go from A to C, that means I'm going to be going to the left 2, 1, 2, and I'm going to be going down 1. Okay, so there's my little right triangle right there. And I'm going to find the hypotenuse, C. Okay, the longest side, which is AC. So in order to do that, I'm going to say that AC is going to be, I'll put a little arrow there. Here I'm going to use Pythagorean theorem. A squared plus B squared equals C squared. 1 squared plus 2 squared equals C squared. 1 squared is just 1, plus 2 squared, which is 4, equals C squared. 1 plus 4, 5, you got it, equals C squared. If I take the square root of both sides, then I get that C is the square root of 5. Now you could use C, you could use X. I just kept it as C. And there you have it. AC is equal to the square root of 5. So you know what I'm going to do? I am going to, because I have the ability to, I believe I can move this writing. Can I? Yeah, I can move it over just a teeny bit. Just to keep it a little bit more neater for you. Square root of 5. I just moved it over just a sec. All right. Don't hate me, guys, if you're using a pencil. I apologize. Let me erase this little part here too. Make it a little bit nicer looking. Okay, so this side from A to C is the square root of 5. Okay, so far, 5 is not the same as square root of 5. So far we have two sides that are different. It's looking like I could either have a scalene or isosceles. I don't know. It all depends on what BC is. Okay, so now what do we need to know? We need to know the length of BC. So BC, what is that equal to? Okay, so I'm going to do my work on the right-hand side here. Okay, so from B to C, I'm going to use Pythagorean theorem again. We have the graph paper. Might as well. So from B to C, or C to B, I have to go down 1, 2, 3, 4 boxes down over 1, 2. So down 4 over 2. So that means that when I use my Pythagorean theorem, 4 squared plus 2 squared equals C squared. 16 plus 4 equals C squared. 20 equals C squared. So now the square root, C is going to equal to the square root of 20. All right, so let me erase these little markings here. Just to show you, I erased C, that this side is the square root of 20. Well, that's different. BC is the square root of 20. All sides are different. So if all sides are different, that means that no sides are congruent, right? No sides are equal. So what kind of a triangle are we dealing with here? We're dealing with a scalene triangle. Okay, so triangle ABC, I will write it actually up here. Triangle ABC is scalene because all, or actually instead of all, I guess I didn't want to erase all of that, because no sides are congruent. Okay, no sides are congruent, no sides are equal. You could say all the sides are different. That means the same thing. Okay, so I'm going to highlight that because that's my final answer. That's explaining my reasoning. Okay, we're proving it. Okay, it's scaling because I'm able to explain it, and all that math proves it. All this math over here just proves it because all sides are different. No sides are congruent. Okay, so now we've classified this triangle. Now, who's to say, yeah, it could be scalene, but also scalene has to do with the sides. It could be a right triangle too, right? There could be a right angle somewhere in that picture. I don't know. Maybe it's in this little corner at C. Maybe there's a right angle right there. I don't know. It's a possibility, right? You guys see that little box that I just drew? I don't know. Maybe it is a right triangle. I'm going to erase it. Let's see. The only way to find out is to prove it. Okay, now how do you prove it? Well, in order to have a right angle, you need to have perpendicular lines. And if in order to have perpendicular lines, you need to have something called a negative reciprocal slope, right? Remember that example from yesterday, 2/3. If you have a slope of 2/3, let me go to it actually really quickly without, confusing or making you dizzy. We talked about that yesterday. Here it is in pink, circled in pink. If you have a slope of 2/3, then a slope perpendicular to that would be the negative 2/3, a negative 3/3, right? You have to flip it. Not only change the sign, but you have to flip that fraction. Okay, so if we have slopes that look like that, then we have perpendicular lines. And if we have perpendicular lines, that means you have a right angle. Okay, so a lot of stuff like that, like in life. You gotta have like something first, and then if you have that, then you have something else, right? All right, so here we go. Finding the slope of each side. That's one way to prove that this is a right triangle. Okay, so what are the three sides? The three sides are, we've got AB, we've got AC, and then we have BC. So those are the three sides of the triangle. Now we have to use slope. So the slope formula is y2 minus y1 over x2 minus x1. So m is equal to that. If we can find the slope of each side, then we'll know whether or not we have a right triangle. Okay, AB. I'm going to need to scroll up a little bit to see the points for A and B. All right, so the y's, I'm just going to write xy for now, xy. Okay, this will be the 2, these will be the 1s. All right, so -9 minus a -4, and then 0 over 0. All right, -9 minus a -4, and then 0 minus 0. Okay, those two negatives, right? What do they make? A positive. That's going to be -5, and that's going to be 0. Oh, if you put that in your calculator, you're going to get that this slope is undefined. And it makes sense because it was a vertical line. AB went up and down straight. So anytime you have a line that goes up and down, slope's going to be undefined. All right, let's see if we get anything else. AC. Okay, so now A and C, this is going to be x2, y2. All right, so hopefully you guys have your pencils today. We have some erasing. -5 minus a -4. Let's do that. -5 minus a -4. And then C, the x's for C are -2 minus 0. Okay. I'm trying to go slow so I don't have to get you dizzy again. 2 negatives, make that positive. So we've got -1 over a -2, and A negative divided by negative is a positive. Okay, so the slope of the second line is 1/2. And the slope for AB is undefined. Okay, so those are definitely not negative reciprocals of each other. So far, no right angle. Let's try one more, BC. Okay, so BC. B, I'll make that one x1, y1. Okay, so -5 minus a -9. And then -2 minus 0. Okay, so -5 minus a -9 over -2 minus 0. This becomes a plus. So now we've got 4 over a -2. And that simplifies to just -2. We can actually write that -2 over 1. So now take a look. Take a look of those two slopes. Are those negative reciprocals of each other? If you flip one and change the sign, do you get the other slope, right? If you flip 1/2, right, don't you get 2 over 1? And then if you change the sign, meaning 1/2's positive, the other one should be negative. I think that's what we have here. All right, so that means that AC is perpendicular to BC. They're perpendicular, so that means this is huge here, guys. They're perpendicular, so that means that that little box that I drew before at C, that's really there. I'll highlight it for you guys. That means that that's really there. AC and BC, where they meet at C, right? And they make a right angle right there. I don't want to change the highlighter. Let me change that to black. There we go. We have that right angle right in that corner, and that's huge. So this is what we're going to write. So is triangle ABC a right triangle? We say yes, because AC is perpendicular to BC. And just to kind of get used to the language here, guys. Oh, can I move this out of the way? Oh, maybe not. And perpendicular lines form right angles. Perpendicular lines form right angles. So yes, ABC is a right triangle because AC is perpendicular to BC, and perpendicular lines form right angles. Boom. All right. So we do have a right triangle. This scalene triangle is not just scalene, it's also right. All right, it has that right angle. Okay, one more way of proving if a triangle is a right triangle. There's one more way, and that way is Pythagorean theorem. And you know that formula, a squared plus b squared equals c squared. Now, Pythagorean theorem only works with right triangles. I want you to remember that. It only works with right triangles. So that's why we're using this here. Okay, it only works with right triangles, Pythagorean theorem. So if we take the 3 distances that we found in part A, all right, these are the 3 distances over here. If we take these numbers and plug it into Pythagorean theorem, then that means, and if it works, sorry, I'll explain what it means by, oh, it works, then that means that we have a right triangle. So let's plug in those numbers now. What number goes in where? You know, C is always the longest side, right? C is the longest side. Now, if you put all of these numbers in your calculator, you'll find that 5 is the biggest number. The square root of 20 is like 4 point something. It's not 5. So 5 is the longest side. Okay, remember, the longest side's always opposite that right angle. A little arrow there. I'm trying to draw a little arrow. Let's see if it fits. Yeah. So 5 is the longest side. So 5 is going to go in here. And then it doesn't matter what we put in for A or for B. So we'll put the square root of 5 for A. Why not? We'll square it. Square root of 20 for B. I'll put those in parentheses because we have to square it. And that equals 5 squared. So if this is true, all right, for example, if it said like 1 plus 2 equals 3, 1 plus 2 does equal 3. Here, if the square root of 5 squared plus the square root of 20 squared, if that equals 5 squared, then that means that it works, and Pythagorean theorem says that this is a right triangle. All right, so square root of 5, if you put that in your calculator and square it, you could put it with parentheses. You're going to get this is equal to 5. Plus the square root of 20. If you square that, you're going to get an answer of 20. And 5 squared is 25. Now, I don't know about you guys, but 5 plus 20 is 25. And does 25 equal 25? You bet it does, right? It works. So what does this tell us? This also tells us that triangle ABC is a right triangle. Okay, so since we have a true statement using Pythagorean theorem, I'll write this because it's shorter. Using a squared plus b squared equals c squared, triangle ABC is also a right triangle. Okay, hopefully you can write a little bit neater than I am on my iPad right now. But there you have it, guys. This is 2 ways. I wrote it at the top in the question. Oops. These are 2 ways of proving that something's a right triangle. Okay? So you could either do it by finding the slope of each side and seeing whether or not the slopes are negative reciprocals of each other, right? They have to be negative reciprocals. Let me write that down. They have to be negative reciprocals. That's what the flip and change the sign means, or is called. Okay, if you have that, then you have perpendicular lines, and perpendicular lines make that right angle. All right, or you could do Pythagorean theorem, which only works for right triangles. All right, if you plug the 3 sides in that you figured out in part A, you know, it was for good reason why we did that in part A. Now, we know for sure 1000% that the triangle and above is also a right triangle. So ultimately, guys, triangle ABC is a right scalene, or actually what sounds better, right scalene or scalene right triangle? Is a right scalene. I think scalene first sounds a little bit better, but you could change, it doesn't matter. Is a scalene right triangle. Okay, so I think this is pretty cool stuff. Like this is what geometry is all about. It's, hey, here's a picture, here's some formulas. Now do something about it, you know? Prove something. And don't just say, oh, well, it's a triangle, it's scalene because, I don't know, just looks like it. No, we're actually using mathematical facts and calculations to prove a statement. And that's what it's all about. Okay, so I know I spoke a lot today. I talked a lot. I know this was one huge question, but listen to it again. All right, if you have some time, or if you are confused about any little particular section of this problem, go back, look at it again. Sometimes hearing it a second, even a third time, it'll sink in a little bit better, and maybe you'll have a better understanding of everything. Okay? All right. I spoke enough today. Have a great rest of your day. Email me if you have any questions. The Delta Math is there for you. Remember, it's due Friday. And also, give question number 3 a shot. Okay? You can do this. I know you can. It's the same thing as question number 2. I promise the triangle won't be as tiny. Okay? And use whatever method you like to prove the triangle is a right triangle. All right, it says choose one way to prove this. You know, would it be cool if you did both ways? Yeah, that would be cool because one side could, you know, kind of like back up the first way that you choose. All right, try it out. Okay, have a great day and